Hello everyone, in this video we're going to pick up where we left off in section 10.4 with example 7 here. So we want to find the horizontal and vertical tangent lines to the graph of r equals 2 times the quantity 1 minus cosine theta, where 0 is less than or equal to theta is less than 2 pi. So in order to find vertical and horizontal tangents, we need to find when the derivative of x and y is equal to 0, right? That was what theorem 10.11 told us, or even just this discussion right up here. So we need to find our parametric equations for x and y, right? Just like we did before. So let's find parametric equations for x and y, right? So I'm going to do the same thing I did before. This is what r is, right? So in general, x is equal to r cosine of theta. But again, what is r? R is given by the problem, so that's 1 minus cosine of theta. And then I'm going to multiply that times cosine of theta. So shifting this over a little bit, I end up getting let's see, do we want to simplify that one? Yeah, let's go ahead and simplify that one to be 2 cosine of theta. I guess I can put it down here. 2 cosine of theta minus 2 cosine squared theta, once I simplify that. And y is going to be, let's scoop this back over since I don't need all this space. Oops. And y is going to be r sine theta. But again, what is r? R is 2 times the quantity 1 minus cosine theta, again times sine theta. So here I end up getting 2 sine theta minus 2 cosine theta sine theta. So those are my parametric equations. Now I'm going to find horizontal and vertical tangents. So what I'm going to do to find my horizontal tangents, remember I get my horizontal tangents when my y derivative is equal to 0, because the y derivative is what's in the numerator of my derivative, right? So I need dy over d theta, my y derivative. So in order to do this, this is y. The first term is just a regular derivative. The second one I'm going to have to use the product rule. Right, so the derivative of sine is cosine, so I did 2 cosine of theta. I'm going to factor out the minus 2 there, and now I'm going to do the product rule with cosine times sine. So the derivative of cosine is negative sine theta. Leave the sine theta alone, plus leave the cosine alone. What's the derivative of sine? Well, that's cosine. So I end up getting 2 cosine of theta. Now simplifying, distributing the 2 as well, I end up getting plus 2 sine squared theta minus 2 cosine squared theta, right? And unfortunately, I cannot do sine squared theta minus cosine squared theta. This doesn't simplify into 1 like you think it should, right? Because remember, the Pythagorean identity says that cosine squared theta plus sine squared theta gives us 1. However, I can rewrite this as follows. I can rewrite sine squared theta as, what is sine squared theta? From the Pythagorean identity, sine squared theta is equal to 1 minus cosine squared theta, right? So that's what I'm going to write there. So I get 2 cosine of theta plus 2. Now instead of sine squared, I'm writing 1 minus cosine squared theta minus 2 cosine squared theta. So simplifying this, let's see what we have here. Let's pull out a 2. If I pull out a 2, I'm left with cosine of theta plus 1 minus cosine squared theta minus cosine squared theta. Right, if I pulled out a 2 out of all those terms. So now simplifying this, let's pull out a negative sign. Well, actually, let's just simplify it so you'll see why. So let's write negative cosine squared theta. I'm going to write these two terms. I'm combining them and writing them first. Plus cosine of theta plus 1. And the reason why is because I see a squared cosine and a regular cosine and a constant. So I'm thinking in the back of my head, I could factor this, right? So because of that, it's always easier to factor with my coefficient of the x squared term or the whatever is being squared to be positive. So let's write this as cosine squared theta, because I pulled out a negative 2, minus cosine of theta minus 1, right? So this, what's inside the parentheses here, think about it as like, and I should have had another 2. I apologize. So let me fix this. Right here, let's see here. So 2, 2, 2, 2, 2, 2. Okay, because these two I combined together to make negative 2 cosine of theta. So I should have written here negative 2 cosine of theta. So I apologize, messed up my algebra there. So this was negative 2 cosine of theta. So when I factored out the negative sign, I should have gotten here. Try this again. I factored out the negative. So 2 cosine squared theta minus cosine of theta minus 1. Okay, that looks better. So now this behaves like 2x squared minus x minus 1, right? If I kind of made like a u substitution with cosine equals u, or maybe an x substitution with cosine equals x. So how would I factor this if it looked like this? Well, I could factor this as 2x plus 1 times x minus 1, right? That's how that polynomial would factor. So I could factor the cosine thing the exact same way, except for cosine in terms of, in place of x. So in other words, I can factor this as negative 2, and now 2 times cosine of theta instead of x plus 1, and cosine of theta minus 1, right? Okay, and I was doing all that factoring of my derivative because now I'm going to set it equal to 0, right? I want my derivative, which is minus 2 times 2 cosine of theta plus 1 times cosine of theta minus 1. I want that equal to 0 because I was trying to figure out my horizontal tangents where that derivative equaled to 0, right? So by the zero product property, right, these two things being multiplied times each other equal to 0. So either 2 cosine of theta plus 1 equals to 0, or cosine of theta minus 1 equals to 0. Okay, so here I get that cosine of theta equals to negative 1/2, or cosine of theta equals to 1. So where does cosine of theta equal to negative 1/2? Well, that happens at 2 pi over 3 and 4 pi over 3. If we look at the unit circle, right? 2 pi over 3 and 4 pi over 3. And where does cosine equal to 1? Well, at 0, right? And because remember, why am I picking those values? Because 0, remember, my theta goes between 0 and 2 pi, right? So these two values lie before 2 pi, and this, my next value that cosine would be equal to 1 would be at 2 pi, but again, I don't include 2 pi because it tells me not to. Okay, so again, I can't verify completely that those are where my horizontal tangents occur because I got to make sure that that my vertical tangents don't also occur there, right? Because if my x derivative and my y derivative both equal to 0, then I can't confirm that it is a horizontal tangent there or a vertical tangent, right? So now I look at my vertical tangents. So those happen again when my derivative of my x is equal to 0. So the derivative of my x, let me go ahead and just copy this real quick so I don't have to keep, this is my x, right? So when I go to take my derivative, I get 2, well, I'm at minus 2 because the derivative of cosine is minus sine. So I get minus 2 sine of theta, and then here I'm going to need to use the chain rule, right? Because it's like u squared. So I pull the power down, I get minus 4, leave cosine theta alone, and then what's the derivative of cosine? negative sine theta. All right, so this derivative ends up being minus 2 sine theta plus 4 cosine theta sine theta. So minus 2 plus 4 cosine theta sine theta. Okay, and now maybe let's go ahead and put this down here actually, because I'm going to do more work. Remember, I'm going to set this equal to 0, so I want it to be like factors being multiplied times each other. What occurs in both terms? I see a sine theta, and I also see a 2. So let's factor out a 2 sine theta. If I do that, I'm left with negative 1 plus 2 cosine of theta. Right? Okay, so now I'm setting this equal to 0, right? I'm saying 2 sine theta, and then negative 1 plus 2 cosine of theta equal to 0. So again, by zero product property, I know that 2 sine theta equals to 0, or cosine, or I'll try that again. Negative 1 plus, just put an or there, right? Or negative 1 plus 2 cosine of theta equals to 0. So here, this is where sine of theta equals to 0 if I divide by 2. So that happens, sine is equal to 0 at pi over 2 and at 3 pi over 2. So sine of 0 is 0. Hold on a second, that doesn't quite seem right. Sine of 0. Oh, sorry, those are when cosine's equal to 0, right? Sine is going to happen at, sine is going to be 0 at 0 and at pi, right? Not pi over 2. Okay, so then now here I would get cosine of theta equals to 1/2. So when is cosine of theta equal to positive 1/2? This time happens at pi over 3. Oops, pi over 3 and 5 pi over 3. Right? Okay, and so we have a little bit of an issue, right? At the angle theta equals to 0, I have my x derivative, or my y derivative equals to 0 at theta equals to 0, and my x derivative equals to 0 at theta equals to 0. So that is a value that I must exclude, right? So we cannot determine whether a horizontal or vertical tangent happens at, scoot this over, see if I can squeeze this in here, theta equals 0. Right, because it's a horizontal and a vertical tangent. Right? Really struggling with that. I screwed that all up, didn't I? Let's just leave it like that. Theta equals to 0. Okay. So, but we do know we've got all the places where I have horizontal and vertical tangents, right? So I have a vertical tangent, right? That happens at, sorry, let's do my horizontal tangents. Right? The first one happens at theta equals 2 pi over 3. So at theta equals 2 pi over 3, what is my r equal? R is 2 times 1 minus cosine. So 1 minus cosine at 2 pi over 3 is equal to cosine at 2 pi over 3. Cosine at 2 pi over 3 is going to be negative 1/2. So I get 2, 1 minus or plus 1/2 gives me what do I end up getting here? I end up getting 3/2 times 2, so this gives me 3. Right, so that corresponds to the point 3 and then 2 pi over 3. At theta equals 5 pi over 3, right, that's where my other one happens, right, or sorry, no, 4 pi over 3. My r is equal to 2, 1 minus cosine at 4 pi over 3. Cosine at 4 pi over 3 is negative 1/2 again. So 2, 1 minus 1/2. So this is positive 1/2 here. And then that equals to 3. So I get the point 3, 4 pi over 3. And then I get here for my vertical tangent, at theta equals 2 pi, I get r equals 2, 1 minus cosine at pi. Cosine at pi is negative 1, so 2 and then 1 plus, or 1 minus 1. All right, because cosine at pi, whoops, no, sorry, 2 minuses, so that's plus, so I end up getting 4 here. So I get 4 pi at theta equals pi over 3. R equals 2, 1 minus cosine at pi over 3. Cosine at pi over 3 is going to give me 1/2. So 2 and 1 and then minus 1/2 is going to be 1/2 times 2 gives me 1. So I get the point 1 pi over 3. And then finally, at theta equals 5 pi over 3, r equals 2, 1 minus cosine at 5 pi over 3 equals 2, 1 minus cosine at 5 pi over 3. 5 pi over 3, cosine is positive 1/2. So I end up getting 1 here, which is 1 5 pi over 3. Awesome. Okay, so that's the end of that problem there. Those are where I have horizontal and vertical tangents, and if I look at the graph up here, you will see that that's where all of those happen, right? And this right here was that point that we weren't sure what happened at theta equals to 0. Okay, so one more here. This one will actually be a little bit easier. So for the polar equation, r equals 2, 1 minus sine theta, we want to find the derivative, dy over dx, and the slopes of the tangents. So the other cases, we're finding where the derivative, we're finding where it had horizontal and vertical tangents. So we were setting the derivatives equal to 0 and finding values of theta. Here we're not doing that. Here we want to find the derivative function and then plug in these given values, right? So first things first, in order to find dy dx, I need to find my parametric equations for x and y. So x equals r cosine of theta, but in this case, what is r? R is 2, 1 minus sine theta, and then we multiply that by cosine theta. So I end up getting 2 cosine of theta minus 2 sine theta cosine theta. And now y is r sine theta. So that's 2, 1 minus sine theta times sine theta, which gives me 2 sine theta minus 2 sine squared theta. Okay, So now I need to find my derivative. Find dy over dx. So in order to find dy over dx, I need dy over d theta and dx over d theta, right? So dy over d theta, the derivative of my y. In order to do that one, I'm going to do regular derivative and then chain rule. Right, so the derivative of sine is cosine, so I get 2 cosine of theta minus 2, and then I get 2 sine theta chain on the cosine theta. So I end up getting 2 cosine theta minus 4 sine theta cosine theta. Right? One thing I should note here is for this example 8, I could just use, once I have my polar equations, I could use this formula. Right? So in other words, I could use this formula right here. I don't like to memorize that formula though. That's why I'm doing it the way where I find the y derivative, I find the x derivative, put them over top of each other. But if you so choose, you could use that formula up there. So I should note that. Okay. So now that's my x derivative, or my y derivative. Let's find my x derivative. Dx d theta is going to be the derivative of cosine of sine, so minus 2 sine theta minus 2. Now I'm going to do the product rule. So cosine theta times cosine theta plus leave sine alone times the derivative of cosine, which is minus sine theta. So I end up getting here that this one is minus 2 sine theta minus 2 cosine squared theta, and then minus minus, that's plus 2 sine squared theta. Again, I can't make this 1 at all because I have a minus sign there, so I just have to leave it. Right? So I know my y, I know my x, so my general dy over dx now is dy over d theta and then dx over d theta, right? Because they're parametric equations. So my y is 2 cosine of theta minus 4 sine theta cosine theta over top of my x, which is minus 2 sine theta minus 2 cosine squared theta plus 2 sine squared theta. So that is my derivative, my dy dx. So now the question says find the slopes of the tangents at these points, right? Notice that these points are given in polar coordinates, right? These are all polar. They're given a radius and a theta, which is convenient because in order to find the derivative at a point, we need theta, right? So this is actually going to be really relatively easy. So for part A, we have the point 2, 0. Right, so that means theta is equal to 0, just given by the second coordinate there. Right, so at that point, dy dx, I'm going to plug in 0 for theta. So 2 cosine of 0 minus 4 sine of 0 cosine of 0 over top of minus 2 sine of 0 minus 2 cosine squared of 0 plus 2 sine squared of 0. Well, at 0, I know that sine is 0. So that means this one's going to go away, this one's going to go away, and this one's going to go away. So cosine at 0 is 1, so this would be 2 over top of cosine at 0 is 1, square root's still 1, so minus 2. So this slope is going to be minus 1. Right? So the slope, the question asks, find the slope of the tangent. Slope of the tangent line at the point 2, 0 is m equals negative 1. Right? So now let's do the next one. B equals 4, 3 pi over, I didn't see what it was, 3 pi over 2. Right? So again, I want to find the derivative here, so dy over dx. So it looks like 2, again, theta I'm just given to, it's that second coordinate, 3 pi over 2. Remember, that's just down here. That's going to be easy for us to plug in numbers. So I did 2 cosine at 3 pi over 2 minus 4 sine at 3 pi over 2 cosine at 3 pi over 2 minus 2 sine at 3 pi over 2 minus 2 cosine squared at 3 pi over 2 plus 2 sine squared at 3 pi over 2. So notice at 3 pi over 2, my cosine is 0. So that's going to go away. That's going to go away. So my numerator is actually 0. My denominator, it doesn't really matter what it is. In this case, I think it ends up being, this goes to 0. So it ends up being positive 2 here. And then so I end up getting 2 plus 2. So this ends up being 0 over 4, which is just 0. Right? I was right to check the denominator, because if it was 0 over 0, that'd be something different. Right? But this right here is negative 1. Whoops. Because I'm down 1. This right here is negative 1, but then I square it, so that's 1. So 2, and then, so I get 2 plus 2, which is 4. All right, so the slope of the tangent at the point 4, 3 pi over 2 is m equals 0. In other words, I have a horizontal tangent, right? So that's cool. And now let's look at the last one here, 3 7 pi over 6. So 3 7 pi over 6. So again, that means theta is equal to 7 pi over 6. 7 pi over 6, those are the points. 7 pi over 6 are negative radical 3 over 2 and negative 1/2. Both x and y are there. So that's the points that correspond to that for when we do this. Okay, so dy over dx is equal to 2 cosine of radical 3 over, or why am I putting radical 3? I want to put 7 pi over 6 minus 4 sine at 7 pi over 6 cosine at 7 pi over 6, all that over top, minus 2 sine at 7 pi over 6 minus 2 cosine squared at 7 pi over 6 plus 2 sine squared at 7 pi over 6. All right, so cosine at 7 pi over 6 is going to be, so I get 2, and then I get negative radical 3 over 2 minus 4. Sine is going to be negative 1/2. Cosine is negative radical 3 over 2. Then that's all over top of minus 2. Sine is minus 1/2. Minus 2, and then cosine is negative radical 3 over 2, but I'm squaring it, then plus 2, and then I get negative 1/2, and I square it. Right, so my numerator, I end up getting negative radical 3. 2, those cancel out. 3 minuses make a negative, minus radical 3 over top of, here I get positive 1. And then square that, so that makes it 4. So I'm going to get, that's going to be positive. So this would be negative radical 3 over 2 plus, or actually, sorry, the 3 gets squared, right? The radical 3 does. So that should be just positive 3 over 2. And then I get 1/2 squared, so that's going to make it 1/4 and 1/2, so I get this. So I end up getting minus 2 radical 3 over top of 0. Uh-oh, I'm undefined. Right? So the slope at the point 3 7 pi over 6 is undefined. In other words, I get a vertical tangent. because I'm not simultaneously 0 over 0. I'm a number over 0. So my y derivative is not 0, right? So this is truly a vertical tangent, and this was truly a horizontal tangent. All right, that's all I have for this section. Thank you.